Hello, everyone. So we are going to talk about some questions about the functional equation from MATHCOUNTS. So like this is one of the concepts that we don't see that much, but this is also good to know. And it's given like first things first, like the functional equation is an equation where we do not know the function itself. So usually if you know like the function and then you can plug numbers in and get what you want, what you need. But in the functional equation, you don't really know the function itself, which is kind of a bit challenging stuff. So there are some approaches, but for now we are gonna just use some basics, okay? So the first question was a target question, number 8. So f of x plus 1 over x times f of negative 1 over x is given as 3, and we want to find f of 2. So the most common approach to these basics of the functional equation is just plug in numbers and see if that's going to help us somehow. So since we are looking for f of 2, the first number I'd like to choose is just x equals 2. If I choose x equals 2, then you will get f of 2 plus 1 over 2 times f of negative 1 over 2, and this is equal to 3. So like, okay, this is what we want, but there's something right here, negative 1 over 2, which makes our life miserable. So maybe we can plug this number now for x just to hope to see if we can get something better. So if I choose x equals negative 1 over 2, then that will give us f of negative 1 over 2 plus, this is going to be like 1 over x, which is 1 over negative 1 over 2 times f of negative 1 over 1 over 2, but negative 1 over 2. Okay, and this is going to be equal to 3. So let's clean this a bit. So this is okay, but the second one is a bit needs to be clean, right? So if I clean this part and this part, so I will get something like this, f of negative 1 over 2 plus, this is 1 over negative 1 over 2, it's just negative 2. So I can just write negative 2 times negative 1 over negative 1 over 2, just 2. So that means the second part will be just f of 2, which is nicer because we got this now in the second part. So the first one was f of 2 plus 1 over 2 times f of negative 1 over 2. At this point, you can pause the video and try and see if you can finish the rest. And what we want was the f of 2, right? So then f of 2 right here, f of 2 right here, but there's f of negative 1/2, there's also right here. So which is why we need to eliminate these guys. Since this guy have a coefficient of 1/2, this is just 1. Maybe I can multiply the top equation by negative 2. If I multiply this by negative 2, this will be 1/2 times negative 2, which is going to give me just negative 1 times f of negative 1. That's going to be positive version right here. So that will give us the cancellation those. Okay, so this term and this term will cancel after multiplying by negative 2 and adding with the second equation. So now we have the negative 2 times f of 2. So negative 2 times f of 2. And this is gone. And the bottom equation had negative 2 times f of 2 as well. And this is negative 3. This is positive. I mean, negative 2 times 3 is negative 6. And plus 3. So you get negative 4 copies of f of 2. And then this is going to be negative 3 divided by negative 4. So the f of 2 is just the 3 over 4. And we are done. So this was a number like 8, as I mentioned, on a target, so which meant to be challenging. As you see, it wasn't too bad as long as we know how to approach the functional equation. So let's look at another one. So here's the next one. So this is a sprint run on a state test. So we are given f of a plus f of b equals f of a times b for any two positive integers a and b. And what we know is f of 3, and what we want is 27. So like if you plug 3, but for what? A or B or both? So if I plug 3 for A, that will be f of 3, and then this is going to be 3 as well, f of 3. That's a good idea to plug A and B as 3. The reason why I like to choose both to be the same, so we can get the something on the left side that we can actually find it. So that will give us f of 3 plus f of 3 equals f of 3 times 3, right? So f of 3 is 5. So this is also 5, which means the left side is just 10, is equal to f of 9. Okay, so now when you plug 3's for both variable, we got f of 9, which is useful because 27 is what we want. And if you kind of take this guy as 9, maybe, and then this guy as 3, so, and then you are going to multiply those to get 27. So that is actually what we are going to do now. So the f of 9 plus f of 3 is equal to f of 9 times 3, which is just 27. So let me actually write as product 9 times 3. So f of 9 is 10. F of 3 is 5. So that should be equal to f of 27, which is equal to 15. Okay, so that wasn't too challenging. So that was the answer. So let's do one more. Here's the last question. This was a state problem on number 30, so which meant to be most challenging question. So we are given the interval for x value, and the function f of x is satisfying this relation, and f of 1 minus x equals 1 minus f of x, and what is the absolute value of this expression that goes forever. So, okay, so here's the first thing, like, you had to accept. So you have a bunch of terms that you are keep adding, even though it's like f of something, you probably suspect that could be somehow related to series, maybe arithmetic, maybe geometry. So that might be something you should be thinking as soon as we see this one. So, but at the same time, we have no concrete values either. So, which is why we have to start with something. So one of the key way, the approaches is look at these numbers, right? So this is x and this is 1 minus x. If I take the average of these two, like 1 minus x and 1x, that will just be 1 over 2. Why do I care about it? Because if I plug x equals 1 over 2, then the equation right here will give me a concrete number. So let's plug that. So if I choose x equals 1/2, okay, so then 1 minus 1/2 will be f of 1 minus 1/2, which is 1 over 2, equals 1 minus f of 1/2, f of 1 over 2. So if I move this guy to the other side by adding itself, so you will get 2 copies of f of 1/2. So 2 times f of 1 over 2 equals 1. Then f of 1 over 2 is equal to 1 over 2. Okay, this is something. So we didn't have this before, now we do. And but what should I do now, right? Maybe we can plug 1 over 2 into this expression, this relation, to get something else, because we know f of 1/2 is given. So which means if I plug 1/2 for x in this relation, let's see what's going to happen. So you will get f of 1 over 2 over like 1 over 2 plus 1. And this is going to be f of 1 over 2 over 2, because that's the right side. So like this guy will be 3 over 2, 1 over 2 divided by, actually not this way. So like 1 over 2 is the numerator, and the denominator is like 3 over 2, which means I will just write 2 over 3. So these will cancel, so you will get 1 over 3. So that means this guy would be f of 1 over 3 equals f of 1 over 2 over 2. But I do know f of 1 over 2 is 1/2, so that means this is going to be 1 over 2 over 2. So f of 1 over 3 is just 1 over 4. Okay, so this is also another thing we got it. So, but now what? Like we have f of 1 over 2, f of 1 over 3, but what's next, right? So we kind of use this guy, but look at what we are trying to achieve. Maybe that will give us some ideas. So what we want is 2 over 3, f of 2 over 3. So like maybe if I plug 2 over 3 for x in this equation, you will get 1 minus 2 over 3, which is 1 over 3, which we already know. So maybe that is a good idea to use that. So if I choose x equals like 1 over 3 in this relation, this function, so f of 1 minus 1 over 3, this is equal to 1 minus f of 1 over 3. So again, this is f of 2/3. So the f of 2 over 3. And f of 1 over like 3 was 1 over 4. So that means this is going to be 1 minus 1 over 4. So that is 3 over 4. So finally, we were able to get something, which is 3 over 4, the first term. Okay. So after this much work, we were able to get the first term, and now we have infinitely many of these to go. So let's hope for the good. Okay. So, but the next term is 2 over 5 and then 2 over 7. The numbers in the denominators are just the odd number, which is actually telling us something to check. But let's try maybe to see if we can get this next term, right? So you can use some ideas like some like similar like plugging stuff based on what you really look for, like to a fifth. If you want to get to a fifth, right? So maybe you can ask yourself, what should I plug right here? So if I want to get to a fifth, so I'm gonna do like 1 minus x equals 2 over 5. So then 1 minus 2 over 5 is gonna be x, so which is basically 3 over 5. So like if I want to get f of 2/5, so I need to plug x equals 3 over 5. But if I do this 3 over 5 for x, so you will get 3 right here. I mean 3 over 5 for x. So let's see what's going to happen for this guy. So 3 over 5 over 3 over 5 plus 1. And this is equal to 3 over 5 times, this is going to be 8 over 5, so 5 over 8. So that will give me 3 over 8. So, but it doesn't, let me check. 3 over 5 and plus 1, that's going to be 8 over 5. So 5 over 8, so these will cancel. So 3 over 8. But it doesn't really help me, right? So maybe we should try something else to get 2 over 5. So if I want to get 2 over 5 for x instead, maybe we can plug that. If I plug x equals 2 over 5, so you will get 2 over 5 over 2 over 5 plus 1. So that should be 2 over 5. And then this is going to be 7 over 5. So 5 over 7. So these will cancel. So you got 2 over 7. So if this is 2 over 7, maybe I can plug 2 over 7 in this equation to hope something will nice be appearing. So 1 minus 2 over 7. So this is 5 over 7. So look at this, like we got 5 over 7, but we had 2 over 5. So it just didn't really help much, right? So because 1 minus that. So if I want to plug maybe like x as 2 over 5, so that will be 3 over 5. But it doesn't really help me much yet either. But still, you can handle this one if you try to choose a number that is actually giving us the 2 over 5. But I'm going to leave that for you kind of as a challenge. And instead of doing this kind of much work, I'm going to try finding something in general so we can get all the terms immediately. So the things we have in the denominator is just odd numbers. So, you know, the odd numbers are like 2n minus 1 and 2n plus 1, right? In this order, like this is the previous one, this is the next one, if I want to make it in general. So, and if I like apply the 2 over odd numbers, right? 2 over a odd number, 2 over the next odd number. So I can just say, this is like my denominator. This is also denominator of these numbers. So my numbers looks like in function like 2 over 2n minus 1, 2 over 2n plus 1. So this is the term before, this is the term after. So if I take the n equals, let's say 1, right? I mean, n equals 2. This will give us the 2 over 3. If I choose n equals 2, you will get 2 over 5. If I choose n equals whatever, I will get all these terms. That is consecutive. So if I plug now this previous term into this expression, let's see what's going to happen. So the x will be my previous term. So the x 2 over 2n minus 1 over, okay, 2 over 2n minus 1 plus 1. And that will give us like 2 over 2n minus 1. And if I multiply this by 2n minus 1 to make the common denominator, so you will get 2 plus 2n minus 1 over 2n minus 1. And that will give us 2 over 2n minus 1 and 2n minus 1 over. So that will be 2n plus 1. So these will cancel. So you get 2 over 2n plus 1. But what is this? Like, this is actually our next term, right? The inside. So meaning that when you apply this relation into our like numbers in this series, you do get this fraction, this ratio, when you apply the 2 over 2n minus 1, which is any number. Like if you apply 2 over 3, basically, you will get 2 over 5 in this case. So that means this guy right here, f of whatever this expression is going to tell us the f of x divided by 2. F of x is just the term before, which means the next term, this guy, is going to be half of the previous term. So if this is 3 over 4, the next term will be 1 over 2 times 3 over 4. And if you keep doing this, the next term will be 1 over 2 times 1 over 2 times 3 over 4. This is basically just a geometric series. The first term is a 3 over 4, and the common ratio is 1 over 2. If you didn't get this part, please pause and make sure you convince yourself before you move on. As soon as we have the first term and the common ratio, we can find the sum of a series, right? So that was our first term over 1 minus r. This is the case we use when the common ratio is less than 1, which is the case now. So you will get 3 over 4 over 1 minus 1 half. So that should be 3 over 4 times 2 over 1, which is just 3 over 2. So that was a bit challenging, but that is our answer in this case. I hope that was clear. I'll see you in the next